All right, we're simplifying, okay? We've got 2s and 12s and 8s, a lot of things that can reduce here. First of all, I might suggest we just start canceling these guys. That's the 2's gone. You're left with a 4 on the or a 2 on the bottom. 2 also goes into 12. You can do that as well, leaving you with 6. And 6 and 8, we did that before on this same very review sheet. Leaves me with a 3 on the top and a 4 on the bottom. So we can start there. Oh, 3 on top, 4 on the bottom, as I said. Now, there's a bunch of other stuff. And in some cases, it just might even be a better idea to just combine and then simplify more later, because there's an awful lot to keep track of here. So let's look at what we have on top. X to the 9, X to the 4th, and X to the 5th. I'm lining up 4 X's and then 5 more X's. That's a total of 9 X's on top, at least for now. And then you have a Y and another Y squared. That's Y to the 3rd power on top. And this is, again, just clean up so that we don't try and do too much. I've got a single X and an X to the 2nd power. That gives me X to the 3rd, and we'll see what we can do with that later. Y to the 3rd, Y to the 4th, that's Y to the 7th. We have much more in the ways of X's on top. All 3 of these will cancel with 3 of those, leaving me with 6 more up top. All 3 of these cancel with 3 of these, leaving me with 4 on the bottom. So again, clean up shop here. I've got that 3 up top, and I have X to the 6th left on top. On the bottom I have 4, and then I have a Y to the 4th power. So that right there translates to be D. And lastly, this guy is a bit of a beast. I have no problem with showing you how to go through this process. But one thing you may want to consider, you only have one that you can legitimately plug in. That 19 over 2, if you plug that into a Z, you're going to end up with a fraction. And so it's very unlikely that that's going to be one of your solutions. Okay? In fact, I think it's impossible for you to plug in a fraction into one of these and have it go away. Now, the fraction would go away with these, but that's beside the point. You could plug this thing into all 3 of these. Or you can look and see if it's no solution or infinitely many, it's something you're going to have to kind of simplify. So I would look through this. The fact that you have an X or a Y would mean this is probably the equation you're going to want to manipulate. Okay? Now that being said, we're going to combine equations 1, 2, and 3 together in some meaningful way twice. I'm going to have to create an equation 4 and an equation 5 that only have 2 variables. So my guess is that most of us would look at X and Y and Z and say, let's get rid of one of them. And since these 2 numbers are smaller, it might be easier to get rid of Z. So let's plan on that. Okay. What I'm going to do first is recognize that number 1 and 3 can be combined if I simply multiply this equation by a -2. A -2, what that's going to do is turn that Z into a -2Z, and that'll cancel with that 2Z. So that's what I'm going to do first. Equations 1 and 3. And the first one doesn't have to be affected at all. -5x plus 3y plus 2z equals 3. The bottom equation, when I multiply by -2, I'll have a -2x minus 8y minus 2z equals -44. All right. The point of that was to get the z's to cancel. That has been accomplished here. What happens is everything else is a byproduct of that. I got a -7x, I got a -5y, and I have a -41 on the other side. Z is gone. This is my equation 4 is what I can call it. Okay. Now I still need an equation 5, and I need to make sure that that equation 5 does not have a z value. I haven't used equation 2 yet. But if I use equation 2, I can either combine equation 3 by multiplying this by 4, which could get, the numbers will get big, but it shouldn't be a problem. Or I can multiply this equation by 2. That's probably the better choice. But because I normally instruct always go to that one with a single term, I'm just going to be consistent with how I've taught it in the past. The fact that that's already a -4, I can multiply this by 4, and those 2 are going to cancel out. Again, if you want to, you can multiply the top one by 2 and get the same effect. If you want to challenge yourself, then by all means do that. You should get the same answer. So I'm multiplying the bottom equation by 4 now, and I'm going to do that wherever I have more space. Let me actually do that here. Okay. So, putting that aside for now, the second equation, 4x minus 2y minus 4z equals -8. Multiplying this by 4, I get a 4x plus 16y plus 4z equals 88. Okay? These guys cancel out. These don't. Don't get carried away there and cancel things that are the same sign. This is an 8x. That becomes a 14y, and this over here becomes an 80. Okay? That's my equation. Well, these are all even numbers. So one thing I could do is I could divide that by 2. And each of these are going to be simpler. So divide each by 2, and that's going to be my equation 5. That's a 4x plus 7y equals 40. So if I look at these two equations and compare to each other, yeah, I'm going to have to probably alter both of those equations again. And it's just kind of a matter of preference at this point here, because you have a positive here and a negative here. You're either going to go 7 and 4 or 7 and 5. Let's keep it smaller. So I'm going to basically turn the x's into 28s. I'm going to first multiply this one by a 4. That leaves me with a negative 28x minus 20y equals negative 164. 4 times 1 is 4, and 4 times negative 4 is negative 16. That's my equation for adjustment. I want this to cancel with that, so I'm going to need to multiply this thing here by 7. That's going to give me a 28x. Convenient. That's also going to give me a positive 49y. And that's going to give me over here a 280. Okay, 7 times 40. These are gone. 49 minus 20 is equal to 29y. And 280, shame on me, well, no. 280 minus that, 0 minus 4 is 6, but I had to borrow, and so 8 becomes 7 minus 6 is 1, and 2 minus 1 is 1. So the question becomes then, how many times does 29 go into 116? Well, you bump that up to 30. 30 goes into 120 about 4 times. Turns out 116 divided by 29 is in fact, 116 divided by 29 is in fact equal to 4. So divide by 29, y equals 4. We're not done. You plug that back into here, and you get 4x plus 7 times 4 equals 20. That's 28, or 40, sorry. Subtract 28 from both sides, and you get 4x equals 12. X equals 3. You can kind of see where we're going, and some of you may have already circled it by now. But that's why if you tried to plug this in to each equation, it would have worked for each, and it would have saved you having to go through all this stuff. We haven't actually confirmed that that's in fact the case, but if you go back to the original equations, one of the first 3 and plug in the 3 for x, the 3 for x and the 4 for y, 3 plus 4 times 4 plus z equals 22. That's 16 plus 3 is 19. You subtract 19 from both sides, and you get z equals 3, so your answer is C.